So here is our new concept. We are going to learn about matrices. And a matrix, like the movie, is a rectangular array of elements or entries. Okay? Made up of rows and columns. So what we are going to do is we are going to make matrices by basically putting numbers in a big box.
I have found contradictions in the notes. It says they're enclosed by square brackets, but many of your matrices are
Yes.
enclosed by round brackets.
Some of them have square brackets, some of them have round brackets. I like to use square brackets whenever possible. But sometimes, depending on the computer program that you're using, they have round brackets. Mathematicians are inherently lazy, so matrices are nice in that they just hold just a number in certain places. So they can simplify a process, for example, of solving systems of equations. And we're going to see that eventually. Horizontal entries are called rows. Vertical entries are called columns. There's rows and columns. Mm-hmm. It's perfect. It's so nice. It's kind of, I kind of feel like maybe some German roots, right? They can't really use the C, add the K in there. And
Oh yeah, let's just invent part of invent more English.
I love inventing more English. Makes the Wordle harder every day. Okay. A matrix with m rows and n columns is called an m by n matrix, where the m and the n are its dimensions. And in order to do the dimensions, you always have to put the row value first and the column value second. So we need an easy way to remember this. And so we think that matrices rock. The RO from rows, the CK from columns. It works out perfectly. So this would be a 3 by 4 matrix. 3 rows, 4 columns. Oh, where people, the numbers you write in there, if you're writing down, doesn't matter what numbers. Okay? So the dimensions are sometimes called the order. So see if you can state the proper dimensions or state the proper order of these 3 matrices. See if you can write down. Yeah, write down the order or the dimensions of those. Remember, rows first, columns second, matrices rock. All right. See how I did? Did you see that this one was a 3 by 1? 3 rows, 1 column. No, it's not 12.
I'm used to X being multiplication.
I've been getting used to X being an X. Jeepers. And 4 rows, 3 columns. 1 row, 4 columns. Okay? But Aiden, you have to notice that in here, it's going to always be a sans serif X in Century Gothic font. Then you know that it's in a dimensions thing.
What type of Century Gothic? Are we talking like the title font, the body font, the heading font? You kind of need to specify this.
Just its regular font.
And what happens if we put it in serif? Do we lose points if we draw a serif X?
Mm-hmm. You lose You lose a 1, you lose 1 mark, but it's like a 1 with all the serifs, so it's like a bigger 1 than normal. We use capital letters to denote matrices and the corresponding lower letters to talk about their elements. So you could have matrix A, and then you'd look in the element that lies in the ith row and the jth column. It's great for practicing pronunciation here. And you would get the element Aij. And some textbooks will write a comma, wow, between the I and the J, and some will not. Okay? And just like when doing dimensions, when you're talking about an element and labeling it, matrices rock. Row first, then column. Question? Oh, yes, very, very important. Okay. Yeah. In fact, this weekend, I would really spend about an hour practicing by hand Century Gothic. Yeah, that's why I said you might. I said an hour for everyone. That was an average. Aiden may need 3. 3 hours of practice. So, A11, A22, A33. Those will be your diagonal. That's your main diagonal of the matrix.
In this case, it could be like
1, 1 like that, 2, 2 without the comma is fine. The reason the comma comes into play is if you ever get a huge matrix, then you might have to be able to say which is which.
I'm more surprised that they're using numbers to represent like rows and columns instead of say like A, Z, and B.
Nope, they use numbers. Because the letter is already used for the title of the matrix. This is matrix capital A. The elements are little a to say they belong to big matrix A.
Yeah, but it's like. Okay, so what do you mean? So this one's saying matrix A lies in the row I of the and J column, which is A, I, J, and subscript.
Yep.
So
So this, like if I take this,
represents a very specific position on.
that's right.
So are we replacing those little numbers like lowercase I and lowercase j with numbers?
Yes.
Oh, okay.
Yes.
That's what I was asking.
Okay. Nope, that is exactly it, because the I and the J just saying you don't know where it is, so there I was using a variable to say it could be any position. And now, this one that I've circled, that exact element is in the 3rd row and the 2nd column, so we call it A32.
When is it appropriate to use numbers and when is it appropriate to use letters to denote elements?
When they're talking about a matrix in general, right, and I'm talking about any place in there, I'm using variables to do that. When I'm talking about a specific spot, I will be using numbers.
Okay, so we should use numbers when
We're being specific, exactly. So if you have matrix M here, and you want to find M13, you would go to row 1, column 3, and that would be 0. If you wanted to find M34, row 3, column 4, you would get E. And if you wanted to find M24, you would get pi. What's the order of this matrix? 3, pi, notice Century Gothic, non-serif, 4. Ooh. And I'll be like, why are you taking so long to do your test? I have to add all the serifs. Yes, oh. If the first test isn't all in serifs, I sense a redo.
So let me redo my test by Mrs. Sarah.
Force you. See, I don't know, Aiden. I don't know if in this situation, I don't think force is the proper word because Lily would probably enjoy it. See? Mm. The matrix people came up with some very clever definitions. There is the column matrix. It is a matrix with one column. Then there is a row matrix. One row. And you won't guess the shape of the square matrix? Oh, a special kind of rectangle. It is a square. Same number of rows, right? This is a 2 by 2. This is a 1 by 1. Here we have a 3 by 3 and a 4 by 4. I did, right? I said 4. I wrote 3. Yes. Another good example of when you think about the next thing you're going to do. Sometimes, a zero matrix, very fancy, is a matrix that has only zeros. And here's the first one that you probably wouldn't intuitively know what it is, the identity matrix, one of the most important matrices that we're going to work with. The main diagonal are all ones. Everything else is zeros. It is very cool, but you don't know why yet. I have a puzzle, just as a break. There, this one up there. Okay? I can give this puzzle, this is the classic puzzle with the 9 dots is, can you connect all 9 dots with straight lines without lifting your pen? Okay? That's the classic puzzle. Now, the second puzzle is, if these 9 dots are maybe your pet, what animals eat each other? Is there animals that if you put them together eat each other? I'm sure there is. Different types, okay, these are your pet fighting fish. I don't know what kind there. Yeah, there we go, fighting fish. Fighting fish will, yeah. So you love your 9 fighting fish, but if you put them all in the aquarium right now, they will eat each other. So can you separate all 9 fighting fish by using only 2 squares? For example, if I chose one square to be here and another square to be here, these 3 would be alive and there would be blood in these ones, which wouldn't be so good.
Technically speaking, if you put 2 groups of 3 of them together, you do end up separating them because eventually you end up with one fish in each partition.
Right, but you want to keep all your fish. Square. The transpose of a matrix is if you just decide to switch the rows and the columns. So row 1 becomes column 1. Row 2 becomes column 2. And so if we wanted to write the transpose of this one, row 1, 4, 3 becomes column 1, 4, 3. Row 2, 2. And you have the transpose. The transpose of matrix G, the GT. Ooh. A and F, B and E, C and D.